real-time gesture recognition from depth data, through key poses learning and decision forests. This work introduces a real-time gesture recognition from a noisy skeleton stream. We use the Kinect sensor and tracking algorithms to capture human skeletons. Our method learns and recognizes in real time poses and gestures from a compact joint angle skeleton representation. It relies on three main ingredients: a pose descriptor that concisely represents a human body pose, a multi-class SVM learning machine that robustly identifies key poses in real time, and a decision forest built to recognize human gestures, optionally considering time constraints. For each frame, the skeleton stream is a sequence of graphs with 15 nodes, where each node has its geometric position represented as a 3D point in a global Cartesian coordinate system. To describe the body poses, we represent each joint in a local spherical coordinate system. This representation provides invariance to sensor orientation, reduces redundancy and space dimensionality, while preserving relevant information to the classification of key poses. A multi-class SVM method is used to learn poses from the user, based on the pose descriptors. Later, the machine is capable of recognizing the poses in real time. A body gesture is represented by a sequence of a few extreme body poses, referred as key poses. In this example, a gesture simulating a page turn is characterized by the key poses in red. After training the key pose learning machine, the user is allowed to execute and label examples of gestures, which are organized in a decision forest. Finally, the gesture learning machine is able to recognize user gestures in real time. For each gesture performed by the user, the classified key poses are accumulated into a key pose queue. The key pose queue queries the training forest in an efficient manner, returning the corresponding gesture when found. To evaluate the robustness of our key pose learning machine, we designed a key pose set composed of 18 key poses. We asked 11 individuals to perform all trained key poses, achieving an average recognition rate of 94.84%. We also designed a set of 10 gestures. Here are the results for an individual performing these gestures. We can optionally consider time constraints, as in the goodbye gesture. Each recognized gesture can be part of a natural interface that sends commands to an application. Here, we use gestures to control a media player.
Eu devia estar contente porque eu tenho emprego, sou o dito cidadão respeitável. Eu sou a mosca que pousou em sua sopa.
Thank you for your attention.